Hello students, so today I am going to discuss a very important topic of your sets, that is about Venn diagram. Okay, so Venn diagram are mostly represented to show the relationship between the sets. For example, if it is written in a box, okay, rectangular box, okay, and U means your universal set that already you have learned. Suppose I am defining a set A inside this universal set, and inside this set A I am writing some elements, that is 2, 4, 6, 8 and 10. Okay, and outside this set I am writing numbers as 1, 3, 5, 7 and 9. Okay. Now, to understand this Venn diagram, what we are going to do is, if I am telling you to write the elements inside this universal set U, then you have to include all the numbers of range starting from 1 to 10, because all the numbers are inside this universal set A. Okay, and if we are going to write the elements of our set A, so it will be simply 2, 4, 6, 8 and 10. So that means what we can tell, that 2, 4, 6, 8 and 10 are the elements which is present inside the set A, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are the elements present in the universal set U. Okay, so in this way we get the idea by looking at the diagram. So there are some more examples I can show. Suppose you have another rectangular box here, and suppose I am taking A, okay, and I am writing 2, B, 4, 6, 10, 8, 1, 3, 9, 5 and 7. Now in this diagram, first let us write the elements which is present inside the universal set. Okay, so inside this universal set it will be 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, now what will be the elements present inside the set A? So inside the set A it will be 2, 4, 2, 8, 10. Is it? No. Okay, so what is here? It will be 2, 4, 6, 8 and 10, because all the elements are present inside this circle. So we have to write all the elements. Okay, now if I want to write the elements present in B, so this is the B element here. So what are the elements present? Only 4 and 6. Okay, that means we can conclude that B is a subset of A, is not it? B is a subset of A, and A is subset of U, and B is also the subset of what? U, because element present in set B is also present in U. That's why B can be a subset of U, and elements of B is also present in the subset of A. That's why B is also becoming the subset of A, and elements of A is present inside the elements of U. That's why A is also the subset of U. Okay, so in this way we can get the idea by looking at the Venn diagram, how many elements are there in the universal set, how many total sets are there, how many elements is present in an individual set. Now let us learn some few operations. So there are some operations on sets. first is known as the union of sets. Union of sets, which is shown by capital U. Next, you have intersection of sets, inverted U. Okay. And third, known as disjoint sets. Now let us try to discuss using Venn diagram. Suppose how the union, suppose this is a universal set and there are two sets. Okay, now when I am talking about union, that means union will go for all the element present in A as well as element present in U. For example, if I write A equal to 1, 2, 3, and if I write 2, 3, 4, 5, 6 are the element present in B, so what will be my A union B? That is all the elements of A as well as all the elements of B. That is 1, 2, 3, 4, 5 and 6. So union will take over all the elements present in the first set and elements present in the second sets. Next is intersection. So in intersection, whenever you have two sets, that is A and B, so intersection will be the common element between the sets A and B. Suppose if I write 1, 2, 3 and I am writing here B as 2, 3, 4, 5 and 6. So what will be the common element is 2 and 3. Okay, so intersection means the common element between the two sets. And third is disjoint. Disjoint means two different separation between the sets where there is nothing common between. So they are having no common element and they are written separately. That's why they are known as what? Disjoint sets. Okay. That is, disjoint means suppose A is having element 1, 2, 4 and 6 and B is having element 3, 5 and 7. So if you see here, there is no any common elements. That is, A intersection B is 5. Therefore, these two A and B are called disjoint sets because there is no any common elements in between them. Okay, so that's why they are known as disjoint sets. Okay, so next is some properties of operation for intersection. There are some properties for union also and for intersection also. Okay. So union laws are A union B is always equal to B union A. Okay. A union B union with C, if there are three elements, then if you see here, if you compare A union B, the element that is present in A union B, the answer, again if you union with the third set C, it will always be equal to A union B union C. The third is A union phi is always A. A union A, same sets, union with same set will be always A. Union, universal set, union with A will be U. Okay, so these are the laws for union. Similarly for intersection also, A intersection B will always be equal to B intersection A. A intersection B intersection with C will be equal to B intersection C, again taking intersection with A. Third is phi intersection A will be phi. Okay, and A intersection A is always A. And the fifth is A intersection with B union C is always equal to A intersection B, A intersection B union A intersection C. So this law and this law are known as what? Commutative law, isn't it? This law and this law are known as your associative law, and the third law of intersection, this is known as your associative law. So I think all of you have heard this term, commutative. Sorry, this will be your distributive, okay? This is known as distributive and this is known as associative law, okay? And this law is known as, that is A intersection A is known as idempotent law, which this type of question comes as your 1 mark, okay? So they are known as what? Idempotent law, okay? And one more topic I want to discuss that is very important, and the last part from this Venn diagram is your difference of sets. Okay, now if I shade only this part, okay, and in this, if I shade only this part, so there is a meaning, okay? This whole part is A, but this shading part will be termed as A minus B, okay? This whole part is B, but I'm shading only this part, so this will be known as B minus A. So I'll take a few examples and I will try to help you out how to do it, okay? Suppose in set A, if you are having elements 1, 2, 3, 4, 5 and 6, and in set B you have 2, 4, 6 and 8. So there is some answer difference will be coming in A minus B and in B minus A. So first of all, you see what are the common elements is 2, 4 and 6, isn't it? If you see, intersection between A and B are what? 2, 4 and 6, isn't it? The common element is what? 2, 4 and 6. But my question is A minus B. So what is the meaning is that you have to include only the element which is present in the from intersection part, okay? From the common part you have to only write down the element which is present in set A. So my answer will be simply, so 2, this part shading is there, so A minus B, if you see 2, 4 and 6, here 2, 4 and 6, so these 3 elements are present as an intersection, isn't it? That means 2, 4 and 6 will be lying here, is not it? And 8 is here, okay? So these are the, see how to show it in the Venn diagram I am showing you all. In your set B, this is the whole part is set B, isn't it? That is 2, 4, 6 and 8. But what we are first writing is the common element. First, all of you, when you are doing your Venn diagram, all of you must see is there any common element between the two sets, okay? So between the two sets you are having common element is 2, 4 and 6. That's why I'm writing in the common part, okay? After that you see, if you see here, this B element is having how many elements? 2, 4, 6 and 8. So 2, 4, 6 and 8. And in whole set A, already 2, 4 and 6 are already in between. So what is left here? Is your 1, 3, 5. So this shading part you are asking is there. That's why the answer will be 1, 3 and 5. Okay. Similarly, for this answer will be what? B minus 8 will be, B minus A will be 8. Okay, one more example I will take here. Suppose if you have a V set as A, E, I, O, U. Okay, and another set B is your A, K, A, I, K, U. Okay, first of all, you have to draw the Venn diagram. So now your set is not A and B, it is simply V and B. Okay, after you check what are the common element, is there any intersection element between V and B? Yes, that is A, I and U. So A, I and U, you write down here, common element. Then inside the B, how many elements should be there? 1, 2, 3, 4. Already 3 are written. So K will be written here. And in V, how many elements are there? 1, 2, 3, 4, 5. Already 3 are written. So what we will write? E and O. Okay. Now when I'm writing V minus B, that is only this part you have to write the element. That is E and O. And for B minus V, it will be simply K. So I hope all of you understood the concept of difference of set. Difference of sets ot ami ki koribo lage okol junbur common element thake hebur bad di remaining elements present in your V we have to write, or if B is written before the second set minus first set, you have to write the element left out present in the sets. Okay, so this is the using Venn diagram also you can get the answer, or directly also, but Venn diagram is why it is required. I think all of you understood. To have a general idea, descriptive idea, we require to draw the Venn diagram. Okay, because it helps us to understand the concept more clearly.